Welcome to our deep dive into scenario-based Java interview questions for experienced developers. In today's competitive tech landscape, interviewers are looking for more than just textbook answers. They want to see how you apply Java concepts to real-world production challenges. We'll explore the top 20 questions that test your ability to solve practical problems, covering everything from concurrency and memory management to design patterns and edge case stability. Whether you're preparing for your next big interview or aiming to sharpen your Java skills, this guide will help you approach each scenario with confidence and clarity. Let's get started and unlock the secrets to mastering Java interviews. Scenario-based questions are designed to evaluate your ability to apply Java concepts to real production problems. It's not just about reciting definitions, but demonstrating how you would handle challenges that arise in the workplace. Interviewers for experienced roles often focus on areas like concurrency, JVM memory management, collections, Java 8+ features, and design patterns. They want to see how you approach problems, weigh trade-offs, and ensure stability under edge cases. This video will guide you through each scenario, helping you practice answers in a way that mirrors actual interviews: problem, approach, and trade-off. Imagine you have a large list of objects and need to remove duplicates efficiently. The best approach is to use a set which automatically ensures uniqueness. HashSet is the fastest option, while LinkedHashSet preserves insertion order. For custom objects, it's crucial to override equals and hashCode methods correctly. This ensures that your objects are compared based on their actual content, not just their memory addresses. By converting your list to a linked HashSet and then back to a list, you get a collection free of duplicates and maintain the original order. Null-pointerExceptions can be a nightmare in production code. Instead of catching and hopping for the best, prevention is key. Always perform null checks at boundaries such as API inputs. Return empty collections instead of null values to avoid unexpected failures. Use optional only when it genuinely improves code clarity. For example, you can wrap a potentially null result in optional and provide a default empty list if the value is absent. This approach keeps your code robust and reduces the risk of runtime errors. Creating a thread-safe singleton class in Java is a common interview scenario. The Enum Singleton is a safe and simple solution, especially regarding serialization and reflection. Another practical approach is the Bill Pugh method, which uses a static inner holder class for lazy initialization and thread safety. By encapsulating the singleton instance within a private static holder, you ensure that it's created only when needed and is safe across multiple threads. This pattern is widely used in production systems for its reliability and simplicity. The method throws a checked exception. You don't always need to handle it with try-catch. Instead, you can propagate the exception using the throws keyword in your method signature. This approach is clean and allows the calling method to decide how to handle the exception. For example, if your readFile method might throw an IOException, simply declare it with throws IOException. This keeps your code modular and avoids unnecessary catch blocks, making exception handling more manageable. Caching is essential for performance optimization in Java applications. The design depends on your requirements. For simple in-memory caching, ConcurrentHashMap is effective. In production, consider using advanced solutions like Caffeine, Ehcache, or Redis. Don't forget about eviction strategies such as LRU, least recently used, or TTL, time to live, to prevent memory leaks. Cache invalidation is often the hardest part, so mention it during interviews to show your awareness of real-world challenges. Current modification during collection iteration can lead to runtime errors. To safely delete elements while iterating, use Iterator.remove. For read-heavy lists, copy-on-write ArrayList is a good choice as it avoids modification issues. When dealing with concurrent maps, ConcurrentHashMap is the preferred solution. By using these approaches, you ensure thread safety and prevent unexpected behavior in multi-threaded environments. Memory leaks can cripple Java applications. To detect them, use tools like VisualVM, JProfil, Urkit, or Eclipse MAT. Take a heap dump and analyze the retained size to identify problematic objects. Common culprits include static references, caches without eviction, and unclosed resources. By systematically checking these areas, you can pinpoint and resolve memory leaks, ensuring your application remains stable and efficient. Mutability is a cornerstone of safe Java design. To create an immutable class, declare it as final, use private final fields, and avoid setters. For mutable fields like lists, make defensive copies in the constructor. This prevents external modification and ensures the object's state remains constant. By following these practices, you create robust, thread-safe classes that are easy to reason about and maintain. Sorting a list of employees by salary and then by name is a common requirement. Use comparator then comparing to achieve this. With Java streams, you can easily sort by multiple fields, ensuring a consistent and logical order. This technique is efficient and widely used in production systems for sorting complex data structures. Stopping a thread safely in Java requires careful handling. Use interruption or a volatile flag to signal the thread to stop. Avoid deprecated methods like stop, which can cause unpredictable behavior. By implementing a running flag and checking it in your thread's run method, you ensure a graceful shutdown and maintain thread safety. Handling exceptions in multi-threaded applications is crucial for stability. Use uncaught exception handler for threads to catch unexpected errors. When using executor service, handle exceptions via FutureGet, which wraps them in execution exception. This approach ensures that exceptions are managed properly and don't cause silent failures in your application. Deadlocks can halt your Java application. Detect them using tools like JStack, JConsole, and VisualVM. Programmatically, ThreadMX find deadlock threads helps identify deadlock threads. By monitoring thread states and using these tools, you can quickly spot and resolve deadlocks, keeping your application running smoothly. Resource cleanup is vital for preventing leaks and maintaining performance. Use try-with-resources for automatic cleanup of files and database connections. This best practice ensures that resources are closed properly even if exceptions occur. By adopting try-with-resources, you make your code safer and more reliable. To prevent method overriding in Java, mark the method as final. If you want to prevent inheritance altogether, mark the class as final. This ensures that your implementation remains unchanged and protects critical logic from being altered in subclasses. It's a simple yet effective way to enforce design constraints. Comparing two JSON strings logically requires parsing them into structured objects. Use libraries like Jackson's Object Mapper to convert JSON strings into JSON node or maps. Then, compare these objects for equality. This approach avoids issues with raw string comparison and ensures accurate, meaningful results. Handling large files in Java requires efficient memory management. Stream the file line by line using bufferedreader or files lines to avoid out-of-memory errors. Always close streams properly to release resources. This method allows you to process massive files without overwhelming your application's memory. Retry logic is essential for handling transient failures. Use exponential backoff and set a maximum number of attempts. In real systems, libraries like Resilience4j or Spring Retry provide robust solutions. By implementing retry with backoff, you increase reliability and prevent overwhelming external services. Immutability is the easiest way to achieve thread safety. Use final fields, avoid setters, and ensure no shared mutable state. Immutable collections further enhance safety. By designing your classes to be immutable, you prevent race conditions and make your code easier to maintain in multi-threaded environments. Scheduling recurring tasks in Java is straightforward with scheduled executor service. It's preferred over timer for its reliability and flexibility. You can schedule tasks to run at fixed intervals, such as every 10 seconds, ensuring consistent execution. This approach is widely used for background jobs and periodic maintenance tasks. The producer-consumer problem is classic in concurrent programming. Use blocking queue for a clean and efficient solution. Producers add messages to the queue while consumers take messages from it. This approach handles synchronization automatically, preventing race conditions and ensuring smooth data flow between threads. Stability under edge cases is a hallmark of experienced Java developers. Always consider how your code behaves with unusual inputs or boundary conditions. Implement thorough validation and error handling to prevent unexpected failures. By anticipating edge cases, you build resilient systems that perform reliably in production. Concurrency and multithreading are central to high-performance Java applications. Use thread-safe collections, proper synchronization, and avoid shared mutable state. Tools like Executor Service simplify thread management. By mastering these concepts, you can build scalable and efficient systems that handle multiple tasks simultaneously. Understanding JVM and memory management is crucial for optimizing Java applications. Monitor heap usage, garbage collection, and identify memory leaks. Tools like JProfiler provide insights into memory allocation and performance bottlenecks. By tuning JVM settings and managing resources effectively, you ensure your application runs smoothly. Choosing the right collection is key to performance. HashSet offers fast lookups, LinkedHashSet preserves order, and ConcurrentHashMap ensures thread safety. Understand the trade-offs between different collections such as memory usage and access speed. By selecting the appropriate collection for each scenario, you optimize both performance and maintainability. Java 8 introduced powerful features like streams, lambdas, and optional. Streams simplify data processing, lambdas reduce boilerplate, and optional helps handle nulls safely. Mastering these features allows you to write concise, expressive, and robust code that leverages modern Java capabilities. Design patterns provide proven solutions to common problems. Singleton, factory, and observer are widely used in Java. Understanding when and how to apply these patterns improves code structure, reusability, and maintainability. Demonstrate your knowledge of design patterns in interviews to showcase your architectural skills. API inputs are a common source of bugs. Always validate inputs and perform null checks to prevent unexpected errors. Return meaningful error messages and use defensive programming to handle edge cases. By ensuring robust input handling, you build APIs that are reliable and user-friendly. Eviction strategies like LRU and TTL are essential for managing cache size and preventing memory leaks. LRU removes the least recently used items, while TTL expires items after a set time. Implementing these strategies ensures your cache remains efficient and doesn't consume excessive resources. Defensive copying is a technique to protect mutable fields in immutable classes. When passing lists or other mutable objects, create a copy in the constructor. This prevents external modification and ensures the object's state remains unchanged. Defensive copying is a best practice for building robust, immutable classes. Stream processing in Java allows you to handle large datasets efficiently. Use streams to filter, map, and sort data with concise syntax. Always close streams properly to release resources. Stream processing is ideal for handling big data and complex transformations in modern Java applications. Exponential backoff is a strategy for retrying failed operations. Increase the wait time between retries to avoid overwhelming services. Set a maximum number of attempts to prevent infinite loops. This approach is widely used in network operations and API calls for reliability. Immutable collections are essential for thread safety. Use Java's built-in immutable collections to prevent modification. This ensures that your data remains consistent and avoids race conditions in multi-threaded environments. Immutable collections are a simple yet powerful tool for building safe applications. Scheduled executor service is the preferred way to schedule recurring tasks in Java. It offers flexibility and reliability, allowing you to run tasks at fixed intervals. This is ideal for background jobs, periodic maintenance, and automated processes. Scheduled executor service simplifies task scheduling and improves application reliability. Blocking queue is the cleanest solution for the producer-consumer problem. It handles synchronization automatically, allowing producers and consumers to work independently. This prevents race conditions and ensures efficient data exchange between threads. Blocking queue is a must-know for concurrent programming in Java. Effective resource management is crucial for robust Java applications. Always close files, database connections, and streams properly. Use try with resources for automatic cleanup. This prevents resource leaks and ensures your application remains stable and efficient. When comparing structured data like JSON, parse the strings into objects and compare their contents. This avoids issues with formatting differences and ensures logical equality. Use libraries like Jackson for reliable parsing and comparison. The volatile keyword ensures visibility of changes across threads. Use it for flags and simple variables that are accessed by multiple threads. Volatile is not a substitute for full synchronization but is useful for lightweight thread-safe signaling. Uncaught exception handler allows you to handle exceptions that escape thread boundaries. Set it for each thread to catch unexpected errors and log them properly. This improves error visibility and helps maintain application stability. When using executor service, handle exceptions with FutureGet. This method wraps exceptions in execution exception, allowing you to manage errors from asynchronous tasks. Proper handling ensures that failures are detected and addressed promptly. Thread MXBean provides programmatic deadlock detection. Use find deadlock threads to identify threads stuck in deadlock. Combine this with monitoring tools for comprehensive analysis and quick resolution of concurrency issues. Try with resources is the best practice for resource cleanup in Java. It automatically closes resources like files and streams even if exceptions occur. This reduces boilerplate code and ensures reliable resource management. The final keyword protects methods and classes from being overridden or inherited. Use it to enforce design constraints and safeguard critical logic. This is especially important in frameworks and libraries where stability is paramount. I've covered the top 20 scenario-based Java interview questions for experienced developers. From concurrency and memory management to design patterns and edge case stability, these questions test your ability to solve real-world problems. Practice these scenarios to build confidence and demonstrate your expertise in interviews. Remember, it's not just about knowing the right answer. It's about applying your knowledge to practical challenges. Good luck on your journey to Java mastery.